Okay, so this is the speed and metric review part one. I'll try to make them like 10 minutes long so that you can just scroll through. So this one, we'll just say we'll have numbers 1 through number 11. Okay, so we're going to go through these questions. Number 1 is just King Henry doesn't mind drinking chocolate milk. So the ones that are important are kilo, metric unit, centi, and milli. Okay, but again, this is King Henry. King Henry doesn't mind drinking chocolate milk. All right, number 2, it should be 2.54 centimeters are in 1 inch, and 2.2 pounds are in 1 kilogram. So that's that one. Number 3, 45 centimeters, you're going to want to move it. You're going to divide, 45 centimeters, 100 centimeters in a meter, and it should be 0.45 meters. 8 kilograms, there are 1,000 grams in a kilogram, so this should be 8,000 grams. 1 liter, there are 1,000 milliliters in a liter, so that should be 1,000 milliliters. D should be 12 meters. There are 1,000 meters in a kilometer, so it should be 0.012 kilometers. There we go. I'll get it eventually. And then 8 millimeters. There are 1,000 millimeters in 1 meter, so that should be 0.008 meters. And then lastly, 7 grams, there are 1,000 grams in a kilogram, so that should be 0.007 kilograms. Number 3, so we're converting, so 45 centimeters. Oh no, sorry, this is number 4. Number 4. So we're at 5 inches. We're trying to get to centimeters. So 2.54 centimeters in 1 inch. And so we do 5 times 2.54 and we get 12.7 centimeters. 152 pounds to kilograms, so we are going to do 2.2 pounds in 1 kilogram, and we get 69.1 kilograms. 1 foot starts off, you got to get it to 12 inches, and then from there you can do it to centimeters, and if we multiply that out, we get 30.48 centimeters. The next one, I know this stuff's really exciting, just give me a minute. So 2 pounds, trying to get it to grams, got to get to kilograms first. 2.2 pounds on the bottom, 1 kilogram up top, and then 1 kilogram is 1,000 grams, so you end up getting 909 grams. Next one, 3 days. 1 day is 24 hours. 1 hour is 3,600 seconds. Multiply that through and you get 259,200 seconds. And then the next one, last one of these conversion ones, 691,200 seconds. Trying to get that to days, 3,600 seconds in 1 hour, and then 24 hours in 1 day. And whenever you multiply and divide that out, you end up getting 8 days. Alright, so now we're on to actual stuff that y'all need to know for the test. That's like stuff that's important in the long run. All that stuff before is just, making sure y'all remember how to do conversions. This is actual physics. So remember that the difference between displacement and distance is how far you've gone, and displacement is how far you are from your start. So the guy starts off going 10 kilometers west, then he goes back 10 kilometers east, and then he comes back 5 kilometers west. So for A on number 5, this is number 5, number 5A, what is his displacement? Well, his displacement is this 5 kilometers west, because he goes back and forth, but he ends up 5 kilometers farther west. But for 5B, the distance traveled would be 10 plus 10 plus 5, which would be 25 kilometers. Alright, so make sure you remember distance is how far you've gone total, and displacement is how far you are from where you started. Number 6, a car travels 7.5 meters per second for 12.4 seconds. How far did it go? You need this formula. 7.5 equals d over 12.4 seconds. Solve for d, multiply 12.4 up, and you get 93 meters. This is number 6. Number 7. Number 7, the ant crawls 3 centimeters in 4 seconds. So v is equal to d over t, 3 over 4, but this is centimeters per second. So that's 0.75 centimeters per second, but we need that in meters per second. So King Henry doesn't mind drinking chocolate milk. You're on the C. You need to get to the M. Alright, so you're going to move it 2 spots, 1, 2. So the answer should be 0.0075 meters per second. Number 8. Number 8 says a jet travels at 580 meters per second. So that's your speed. For the first one, we're going to go 500 meters. So what we're going to do is we're going to do v is equal to d over t. So 580 equals 500 over t. You have to get that t out of the bottom. So we end up with 580t equals 500. And then we can solve for t. T is equal to 0.86 seconds. For part B, we've got to convert that to meters first, so it's 8,750 meters. Same formula. We got 580 equals 8,750 over t. Solving for t, we got 580 t equals 8,750. Now you can divide, and you end up getting 15.1 seconds. Number 9. Moving right on through here. Number 9 says a swimmer. So swimmer starts off at 4.6 meters. Okay, and then they do all this swimming. They go back and forth and back and forth and back and forth and back and forth and back and forth, and then they end up right here at 3.2 meters. Now the important thing is displacement is how far you are from where you started. So it's that distance right there, which is 1.4 meters. And they went backwards, right? So we got to make that negative. So that's number 9. Number 10. Number 10. It's just a simple one. You've got a speed of 6 meters per second, and you've got it for 10 seconds. So you know that the distance traveled should be 60 meters. Number 11. This will be the last one we work on this one, and then we'll move on. I'll do another video. During which interval, first of all, your graph looks something like this. So I'll just draw it real quickly. It's steep, and it's nothing, and it's slow. Alright? So that's what the graph looks like, something like this. So this is the 2 seconds, 4 seconds, 8 seconds, and this is 5. And then that right here is 3. So it says during which interval is it moving the slowest? Well, it's moving the slowest here, and so that's the 4 to 8 seconds. The reason it's not this section is because it's not moving there. So for part A, 11A, it's 4 to 8 seconds. B, what's the object doing between 2 and 4 seconds? It's not moving. So between 2 and 4 seconds, it's not moving because it's a horizontal line. What was the average speed for the entire 8 seconds? So stopped for B. So for C, the entire 8 seconds, you would do total distance, which is 5 meters, over total time, which is 8 seconds. So it would be 5/8 meters per second. And then for D, it says at 2 meters. Let's back it up a 0.1 second. So let's say 1.9 1.9 seconds. So let's say like right there. How fast is it going? Remember, you have to find the slope of that line. And so the slope of that line would be 3 meters over 2 seconds, which would be 3 over 2 meters per second, or 1.5. Alright, so that's 11. Alright, now, next video I will do 12 through 22. Alright, so I'll catch you then.